Hi, so I'm going to be solving the USACO 2017 December contest, Silver. Problem 1, my cow ate my homework. So, in your bovine history class, you have given a rather long homework assignment with n questions, which is from the range 3 to 100,000, and each is graded an integer score. And your teacher plans to assign a final grade by discarding a question on which you received the lowest score, which is normal, apparently, and then averaging the remaining scores together, and that's how you get your final grade. Unfortunately, your pet cow Bessie has just eaten your answers to the first K questions. So K can be as small as 1, so it's just at least one homework assignment, and it can be up to all homework assignments except for the last one. So, after a copious explanation, your teacher finally believes their story and agrees to grade the remaining non-eaten part of the assignment the same way as before. So, by removing the lowest scoring question and then averaging the rest. And that's going to be the final grade. So, please output all values of k, which would have earned you the maximum possible score according to this grading scheme in sorted order. So, it has to be in sorted order. Okay, so first let's try out the sample input. So we're going to have 5 questions on this exam and our homework assignment. And for the first question, you get 3, second you get 1, and then so on. 3, 1, 9, 2, 7. So first of all, Bessie needs to eat at least one homework assignment, but not all. So if Bessie eats this homework assignment, we have the numbers 1, 9, 2, 7, and 1 is the lowest number since we're removing the lowest scoring question among the ones that are remaining. So we remove 1, and then we get 9, 2, and 7. So the average of 9, 2, and 7 is 9 plus 2 plus 7 divided by 3 using the average formula. And with that, we can get 6. So if Bessie removes this one, then we get 6 as a score. And let's try the case if Bessie eats the first 2 questions. If she eats the first 2 questions, then this assignment is removed since it's the lowest scoring question, and then we take the average of 9 and 7. 9 plus 7 divided by 2 is 16 divided by 2, which is 8. So the average would be 8. And according to the sample output, that is the highest possible grade. But if there were other values of k, or the amount of questions that Bessie ate, that produce the same output, final grade of 8, then we would have to print all of those out in sorted order. So the first thing that we see as a problem here is that this this number n is going to be way too big to like keep on loop around in a for loop like at least 2 times. Because 100,000 times 100,000 is going to be 10 to the power of 10, and that's going to exceed the time limit by a lot. So we can't solve a problem. We can't solve this problem using a program that uses n squared uh, time complexity. So we have to do this in on time. And for me, the first thing that comes to mind is something called prefix sums, which is where you have a separate array and you store values inside of that array for the sums of all values before and including that index. So let me show this to you in a spreadsheet. So if we work on like a spreadsheet here, let's just use a sample input. So 5, 3, 1, 9, 2, 7. And in this spreadsheet, first of all, what prefix sums is it's finding a fast way. It's a fast way to find all the sums of a certain set of numbers in a given range. So with prefix sums, we would like in an extremely fast at an extremely fast speed, we'd be able to find all the sum of all the numbers from indexes like for example 1 through 3, or 0 through 5, 0 through 4, or like 3, 3 through 4, or 2 through 4, etc. So we can do that extremely fast. And what we can do is we can find, we can keep track of the total sum of the numbers we've seen so far. So if this is 3, this is 4, this is going to make sense after I explain it, but right now I'm just filling it in. So what this is basically doing is this is the sum of all the numbers before this index, including this index. So this is 3, and this number is going to be all the numbers before this index and including the index, so 3 and 1, and etc. So 22 is going to be the sum of all these numbers. So what this basically does is, if we have this separate array, let's call this array um, array B, then in this array B, if we look at the values at index 3, 2, and 4, and then we subtract them, we can instantly find the sum of all the numbers in between them. So let's try that. 22 minus 13 is 9, and this isn't included. So yeah, that's going to be our sum from indexes 2 through 4, which doesn't include 2. And so how can this help us? Well, this question is actually asking, first of all, it's asking to find the average. Never mind the fact that we're taking out the lowest score for now. And if we're finding the average, first, in order to find the average, we first need to find the sum of the values. So if we keep track of the sum of the values in a different array, and then use this method called prefix sums, we can quickly find the average, and we can solve this problem in O(n) time. So all we have to do is we have to sum all the numbers in that specific range of indexes, and then we have to divide it by the difference of the indexes. And as k increases by 1, the amount of indexes we're looking at shortens from 5 to 4 to 3 to 2, and then finally to 1. And here's the final last issue that we have to account for. So if this very odd teacher decides to take out the lowest score, which Bessie receives on the problems, on the remaining problems, so after index k. And what we basically have to do is, for these given ranges, and since k has to be the first k indexes that Bessie is going to eat, it's guaranteed that the remaining questions are all going to be at the end of the array. And what we can do is we can create a for loop that runs from the end of the array and goes through each of these values, logging which ones it has seen, and it finds the minimum. So if we create another array called minimums, then it goes from back to front. So back to front. And first it finds the minimum. The minimum from all the values we've seen so far, which only includes 7, is 7. And after this, the minimum of these two values is 2. The minimum of these three values is also 2. The minimum of these 4 values is 1. And the minimum of these 5 values is also 1. So what this basically does is, when we have a set value of k, we can look at that k index at minimums, and then we can check what the minimum is, so we can subtract it from the sum that we found using prefix sums. And that's basically going to take out the lowest score that we can get. So we're just keeping track of what the lowest score is within certain ranges, and we're putting that in this array. And yeah, after getting this whole idea, and if you know prefix sums, it should be pretty simple to implement this idea. So I'm going to start coding now, and you guys can follow along, and hopefully it makes more sense when I put it in actual text. So first, I import .util and .io. Oops. Soccer my cow ate my home. So let's go over it again. So we need a scanner first of all. It's only going to be 2 lines, so we can probably just write use some kind of string tokenizer for the second line, which is going to just going to contain all the number of points you got for the questions, and it can be up to, let's see, 100,000. So we're definitely going to have to do it pretty fast, and we need a print writer. So we need the integer n, the number of questions, and we need an a way to store like the amount of points we got for each question. And we're going to need an array that gets the minimum value, starting from back to front. And we're going to need sum. Oh, but the problem is that uh, when we're storing these sums, remember that each of these integers are going to be from 0 to 10,000, and there are going to be 100,000 questions. So when you add that all up, in the worst case scenario, it could go to 100,000 times 10,000. And I'm kind of lazy to calculate that right now, but there's a chance it could exceed the integer limit, so I'm just gonna use it as a log, just in case. And when I ever encounter like uh, problems where you have to store large sums, I usually just automatically use a log without calculating because it's just safer that way. And yeah, that's basically it. Public static void. So let's set up the in. I'll set it as .in for now, so we can debug. And comment this out, so we can just access it when we need to. Okay. So first, I'm going to create a separate class called init, where we initialize everything. So n equals in .next next line, because we're going to get a line next. T equals new string token. And then, oh, it's next line for reader. And for y equals 0 as less than 9. So for each question, we're going to be putting it in the array A, so we have to initialize that too. A equals new int n, and if I equals integer dot parse int st dot. So we're getting each of the values inside the string tokenizer. And we initialized other arrays, so min equals new int n, sum equals new long n, and that should basically be it. And then let's create a solve function, which we're going to do all our like important coding. So here, first of all, let's fill the arrays of min and sum, and the fastest way we can do that is in one for loop, where it starts at index n minus 1 and goes down to 0. So for int I equals n minus 1, I is greater than equal to 0, I minus minus, right? And then for the sum, we're going to have another variable that keeps track of the total. So let's just say long total equals 0. and then int current min equals integer dot max value. Because at first, current min is going to have to be the very first question that we're looking at, which means that it should always be the minimum value when we compare it to the initial value. So we have to set it to integer dot max value, and total equals a of I first of all, and then Kermit equals, sounds like Kermit, not related, but okay. Kermin equals math dot minimum, Kermin and a of I. And then sum of I is total, right? Because that's going to be used for the prefix sums, and it's going to be the sum of the numbers after it. And min of I equals current min. Yeah, that's basically it. So now we're going to set values of k from k equals 1 through n minus 2. So we'll have to set the for loop up to n minus like 1, less than n minus 1. So for in k, let's just say k because the integer is k. K equals 1, k is less than n minus 1, k plus plus. So let's calculate the average. And when you're calculating averages, we should always use a double because it could always have decimal numbers, and it's never guaranteed that the average is going to be an integer. So we have to use double. Double average equals sum of k. And then from this sum, we have to subtract the minimum inside that range. So minimum k, then average is divided by n minus k, so that range. And we also have to do minus 1 because there's going to be one less number that we took out that was the lowest number. So n minus k minus 1. And there's actually one last thing we need to consider, which is the fact that here there can be multiple values of k which earn you the maximum possible score. So for that, I am actually going to use a tree map, which is going to have its key as the maximum output, and that it's also going to store the possible k values that can be valid answers for the problem. I'm going to make another tree map, double, remember, and I'm going to make a string so I can just I'm going to put spaces between the answers and then just print it out after splitting it. It'll make sense after I type it. So answer equals new tree map double string. And what we're doing is we're storing the possible k values that work. So if ans.contains key, if it's already inside of the tree map, then you ans.put average, ans.get average. So basically for that specific output or like the grade that the teacher gives, we're adding another possibility, possible value of k. And then else answer dot put average in k plus and then an empty space because it has to be a string. And now that should be it. And then string result equals ans dot get ans dot last key, because tree maps are going to be sorted, so the last key is going to have the greatest output, greatest answer. Ans dot get this dot split by spaces. And for int I equals 0, I is less than rest dot length, right? Equals plus system dot out dot print dot length. Yes. And yeah, that should probably work. Do I have an error? Apparently I do. It's already defined? That is a bit weird. That's weird. But let me run it. Oh, okay, let me see. Oh, okay, I had a separate thing. That was named the same thing. So let's try running it. 531927, and it outputs 2. So I'm gonna try submitting it now. Hopefully it works. And if not, I will debug it again. Let's see. Actually in here. That was my backgrounds, by the way. Here. Yeah, I think this is it. Oh shoot, I didn't change to the files, so bro, I need to change it. Sorry about that. I'm sure most of you caught it while you were watching the video. And then you skipped forward 5 seconds until I caught it too. If you didn't, you're still with me. Nice. Okay, and then you have to throw the error declarations, and now it should work. Like it's good. Okay, yeah, I solved it, and it clearly is under the time limit, so it compiles rather well. And I hope this new method explains some stuff for you and how to solve this problem. And yeah, I hope this video helped.